It has a diameter of over 100,000 light-years and is home to an estimated 200 billion stars. But what do we really know about our home galaxy, the Milky Way? Well, apparently you never stop learning, even on your own galactic doorstep. In fact, in recent months, experts have gathered a series of spectacular insights that shed a whole new light on the Milky Way. And this even starts with a very fundamental point. After all, the latest data suggests that we have been categorizing the Milky Way all wrong this whole time. But that's not all. In the same breath, astronomers have also discovered a gigantic 16,000 light-year structure in our home galaxy and found out that the bizarre gravitational monster at its center has been through something that impressively demonstrates the primal forces of the cosmos to us. To get started, here's a little quiz question. Why is the Milky Way actually called the Milky Way? Well, the fact that our galactic home still has the word milk in its name is thanks to the ancient Greeks. According to an ancient myth, when we look at the starry night sky, we see nothing other than the spilled breast milk of the goddess Hera, a milky pattern that applies not only to our own galaxy, but to all galaxies. After all, the ancient Greek root galaxias means nothing other than milk. But if we now detach ourselves from ancient mythology and instead take a look at the astronomical facts, we recognize that the supposed milk of the gods is, in fact, nothing more than star clusters interspersed with light and dark nebulae. However, since we are located in the middle of the Milky Way with our Earth, it's in the nature of things that this Milky Band, which rises in the southern sky on clear summer nights, by no means represents the whole, but merely a small section of our galaxy. From our point of view, it's simply not possible to see the Milky Way in its entirety. But despite this, astronomers have, in the past, been able to draw a general picture of our home galaxy. The Milky Way is classified as a barred spiral galaxy with 5 of theonomous loose spiral arms, 2 of which we can see in the sky. Furthermore, the diameter of the Milky Way is estimated at 100,000 light-years, although apart from its center, it is only 3,000 light-years thick. And while the thickness of the aforementioned center is about 16,000 light-years, the actual heart of our galaxy appears invisible to our earthly eyes. This is due to the numerous dark clouds that put natural blinders on us with their interstellar matter. But despite all the visual barriers, it is now considered certain that a full-grown monster lurks at the core of the Milky Way. After all, Sagittarius A*, a supermassive black hole with more than 4 million solar masses, resides there. Contrary to what you might think, this is not a galactic exception, but rather the rule. In fact, experts now assume that almost every galaxy center is adorned by such a supermassive gravity monster. When it comes to the much smaller stellar black holes which arise from collapsing stars, experts estimate that there are around 100 million of these bizarre formations in the Milky Way. When it comes to the number of stars, however, astronomers' estimates sometimes differ significantly. While some believe that our home galaxy has only 100 billion stars, others suspect that it's home to as many as 400 billion blazingly bright celestial bodies. Given that data from the Kepler mission and other studies suggest that there are, on average, 1 to 2 planets per star, there could be between 100 and 800 billion planetary worlds in the Milky Way. But not every one of these planets resembles a cosmic twin of the Earth, which is obvious. And yet, in 2022, researchers from Nottingham determined that as many as 36 advanced civilizations could have developed in our galactic home. System misidentifications and gigantic gravitational wells, magnetic halos. Just as in the case of the Earth and the solar system, the Milky Way is not a galactic loner either, but an integral part of much larger overarching structures. On the one hand, the Milky Way belongs to the local group, and thus to a galaxy cluster that has about 35 members. On the other hand, the local group is itself part of the Virgo supercluster, a supercluster of galaxies that is itself part of the Laniakea supercluster. In other words, the local group, including the Milky Way, is subject to the influence of the colossal Laniakea supercluster, or at least that's what we thought until now. A new map of the gravitational catchment areas in the local cosmos now suggests that we have been misplacing our galactic home all this time, and that it actually does not belong to the Laniakea supercluster at all, but to the much larger Shapley supercluster. In principle, such attractors act as gravitational wells, drawing galaxies towards them over a wide area, just as the nature of a landscape determines the course of a river. The study that had assigned the local group to the Laniakea supercluster was based on 8,000 galaxies. But the new study, which the experts conducted on the basis of data from the Cosmic Flows 4 survey, including 56,000 galaxies within a radius of around 1 billion light-years, and where the new wealth of information is significantly more extensive than the old, ultimately led to the discovery that a total of 17 large gravitational wells lurk in our cosmic neighborhood, and that the flows associated with the Milky Way prefer to move towards the Shapley supercluster. Expressed in figures, this means that almost 60% of the structures are flowing towards the Shapley supercluster, which in the case of the Laniakea supercluster is only 40%. All in all, this finding provides astronomers with completely new insights into the gravitational landscape of our local universe. But the phenomenon recently identified by experts at the ends of the Milky Way bar is also completely new because, in fact, we now know that gigantic magnetic structures over 16,000 light-years long originate there, rising far above and below the plane of the galaxy. In the same breath, the special origin of these magnetic filaments also provides a decisive clue to their cause. Since they do not originate from the galactic center, but rather from the outer zones of active star formation, scientists suspect that we are dealing with the result of a supernova collision. In fact, the collective effect of overlapping stellar explosions can eject material at speeds of up to 1,000 kilometers per second, creating the galactic winds. At the same time, the stellar fireworks could be responsible not only for the magnetic filaments, but also for the no less powerful radio structures, which also extend far beyond the stellar disk of our home galaxy. The ongoing study of the Milky Way's structure and dynamics is providing groundbreaking revelations about the cosmos. For example, recent research has shown that Sagittarius A*, the supermassive black hole at the heart of our galaxy, may have experienced a dramatic event in the past, a collision with another black hole. This event, long buried in the history of our galaxy, could have been responsible for some of the odd features astronomers observe today, including the black hole's tilt and rapid rotation. These findings could help to further unravel the mysteries of galaxy formation and evolution. While Sagittarius A* has long been considered inactive, these new insights suggest that it may have had a turbulent past. The collision between two supermassive black holes is a rare but crucial event, with potentially far-reaching effects on the galaxy's structure and star formation. The energetic interplay of these cosmic giants could have influenced not only the surrounding stars, but also the very fabric of space-time in the region. The study of gravitational waves also plays a crucial role in these discoveries. Gravitational wave detectors, such as the Laser Interferometer Space Antenna, LISA, could soon provide direct evidence of black hole mergers, including those that happened in our galaxy billions of years ago. This new form of astronomy is opening doors to observing some of the most extreme phenomena in the universe, giving us unprecedented insights into the behavior of black holes and other exotic objects. As researchers continue to probe the far reaches of the Milky Way, each new discovery brings us closer to understanding the history and fate of our galaxy. The Milky Way, with its immense size, mysterious core, and vast array of stars and planets, is far from the simple object we once thought it to be. Instead, it is a dynamic, ever-changing system, shaped by events that span billions of years. And as technology advances, the next generation of telescopes and observatories promises even more thrilling revelations about our galactic home. Stay tuned for more updates and discoveries from our channel Digital Discoveries, where we continue to explore the vast wonders of space. Don't forget to like and subscribe to keep up with the latest cosmic news and in-depth analyses. Until next time, the universe is waiting for us to discover more.